Hello everyone, I am Fahim and I'll be presenting my survey on machine learning based exploitation and security measures. During the last 2 decades, network security experts have attempted to counter cyber attacks by shortening the amount of time it takes to identify and neutralize threats. Response times have shrunk from days to hours to minutes, but cyber attackers haven't given up. If anything, cyber attackers have become more frequent and more sophisticated with the ultimate tool in hand, that is machine learning. But machine learning also gives security experts and their organization more control over their network and overall security in general. In light of that, I have selected my papers on exploitations and some security measures. The first one is Ghost Talk, an interactive attack on smartphone voice system through power line. The paper focuses on the exploration towards virtual voice assistants. The authors talk about existing attacks that aim at injecting attack signals over the air for activating voice assistant without the authentic user's confirmation. The inaudible voice command injection is launched in this research using a novel channel type called the Powerline side channel. By including audio, the attack becomes more resistant to various environmental conditions and liveness detection models. By transmitting signals through the power line with a customized charging cable. In the meantime, a highly interactive attack is possible because to the modified cable's ability to eavesdrop on the smartphone audio output. The authors launched Ghost Talk and Ghost Talk SC attacks toward 9 mainstream models of smartphones and successfully injected unauthorized voice commands with 100% success rate. The next one is Hand Me Your PIN, inferring ATM pins of users typing with a covered hand. Automated teller machines is one of the most used things in the banking sector. It made smooth and quick transfer possible for millions of the people. These machines use pin combinations to prevent unauthorized access. Unfortunately, this mechanism is vulnerable to shoulder surfing attacks and can be exploited via hidden cameras that are installed on the ATM booth or in that area. To prevent this, people tend to cover their hand, but in this paper, the authors show that that also can be exploited with deep learning methods. They propose a novel attack model to infer pins from videos of users with their covered hand in the ATM booth. The next one is Hello, It's Me, deep learning based speech synthesis attacks in the real world. The efforts and outcomes of a thorough experimental study on the effects of deep learning based speech synthesis attacks on both human listeners and automated systems like uh, speaker recognition and voice recognition systems are presented in this paper. We discover that synthetic speech can successfully deceive both humans and robots and that current safeguards against it are ineffective. These findings demonstrate the necessity of increasing awareness and creating new synthetic speech defenses for both humans and machines. Voice synthesis can become really dangerous tool in the wrong hands. Voice synthesis can lead to many unauthorized access and transactions over a small period of time. Time print, authenticating USB flash drives with novel timing fingerprints. The authors propose an authentication model which is a timing-based fingerprint method for identifying USB mass storage devices. They are able to create a fingerprint by timing a series of read operations from different locations on a drive, as the timing variations are unique enough to identify many USB devices. Usable user authentication on a smartwatch using vibration. This paper focuses on proposing a usable method for user authentication for smartwatches. The authors emphasized on not using any other external devices without the smartwatch itself and its built-in sensors. Their model can authenticate the watch just only observing vibrations from the user's body, and since each human body propagates and reflects vibrations differently, it can detect different vibrations and authenticate smoothly. And the last one is your microphone array retains your identity, a robust voice liveness detection system for smart speakers. Smart home assistant and speakers are more popular than ever. People use these devices to automate their home, and most of the times devices are authenticated by user's voice. In this paper, the authors propose a feature array fingerprint which utilizes the microphone array from the smart devices to determine the identity of the collected audios. They claim their array fingerprint achieves a more robust performance under the environmental changes compared to the previous models that do poorly in same kind of task. This enables the smart systems to be more accurate and stronger, preventing unwanted access from unauthorized locations of users. And now I'll go through each of the paper, discussing their contribution, proposed model, methodology, proposed countermeasure, and highlight important aspect of the papers. Contribution of Ghost Talk. Authors claim this is the first interactive attack towards smartphone using voice assistant which uses the charging cable after slight modification. Ghost Talk can achieve interactive attacks by inaudible audio injection and eavesdropping. But Ghost Talk SC is the better version capable of launching eavesdropping attack without any modification to the charging cable. The authors tested the models on 9 popular brand of smartphones, and Ghost Talk successfully does voice injection and eavesdropping attack with 100% accuracy, while Ghost Talk SC can correctly classify more than 90% digits from the audio. Ghost Talk attacks the smartphones that are charged by the shared power banks, and Ghost Talk SC is able to spy private phone conversation when the phone is being charged by the public chargers. Here is the proposed Ghost Talk model design. The attacker can get access to the audio with the help of the modified charging cable. And the system design of Ghost Talk SC is more robust since it doesn't need modified charging cable. It can get current measurement directly and perform spectrum recognition with the CNN architecture to extract sensitive information. The authors propose also some countermeasures like disabling the activation of voice assistant by headphone. Headphone notifications are recommended to be turned on, and charging should be stopped after reaching the full battery percentages. Moving on to the next paper, Hand Me Your PIN. An attack model is proposed to infer pins from security footage or videos of users with covered typing hand with their non-typing hand on the pin pad. The attack model can reconstruct 30% of 5-digit pins and 41% of 4-digit pins within 3 attempts. The attack was evaluated extensively. 5,800 videos were collected of 5-digit pins and entered in a simulated ATM by 58 participants. The attack model outperforms humans, achieving a fourfold improvement on reconstructing 5-digit pins within 3 attempts. The data was processed and released publicly for the research committee also for further research. And if we look at the model, the attack starts when the victim starts interacting with the pin pad of the ATM. The pin pad emits a feedback sound every time a key is pressed, although the feedback sound is same for all of the key. Some attacker places fake pin pad on the ATM machine which directly gets the data from the victim. However, the authors use a different approach and uses the video footage instead. Data is collected, simulating scenarios, and video is recorded to gather the video of all interactions of the simulation. The attacker's main goal is to infer the victim's PIN. The video timestamps are retrieved, and it can be used to know exactly when the victim is uh, sorry, pressing the keys on the pad. Based on this attack, set is made and different from the training set. Unlike the training set, the attacker set contains sequence of frames for each victim key pressed but no information about the associate level. The adversary detects in the attack set the frames corresponding to a pin entry and divides the video into n subsequences, where n represents the number of digits composing the pin. The adversary uses the model trained in phase A for each subsequence, and the model predicts the likelihood of each class being the corresponding to the input subsequence. Using the end subsequence predictions, the attacker creates a list of pins in descending order of probability. The proposed countermeasures from the authors are to use longer pins. From 4 digits to 5 digits pins are relatively harder to infer, And virtual and randomized keypad can be used other than the mechanical keypad. Also, screen protector or protectors for the pin pad itself can be used for better protection overall. The paper Hello It's Me, Deep Learning Based Speech Synthesis Attacks in the Real World documents efforts and findings from a comprehensive experimental study on the impact of deep learning based speech synthesis attacks on both human listeners and machines such as speaker recognition systems and voice signing systems. The workflow of synthesis based voice spoofing attacks starts with the attacker obtaining voice samples from the victim either by secretly recording them or by downloading available media. The attacker then uses a speech synthesis system to generate fake speech which imitates the victim's voice but contains arbitrary attacker chosen content. The attacker uses this fake speech to impersonate the victim, attempting to access personal or financial information or contact other attackers. Proposed model and takeaways. The authors experimentally evaluate two representative defenses, one detecting synthetic speech using physical artifacts from replay and other one that prevents voice synthesis using embedded audio perturbations. The authors recreates the extraction pipeline from a previous research and trains three models using 2017 ASV spoof dataset. The models are support vector machine with RBF kernel, which had the best performance, light CNN with modified feature set, and custom CNN, which is a 5-layer CNN trained for 25 epochs using Adam Optimizer. The authors conclude that with all the experiment, it is clear that the new and improved defense is needed against synthesized speech attacks, particularly for real-world applications. They propose that more comprehensive investigation is required as current defenses focus on protecting SR systems. Also, an equal need for human-centric defense is also needed. Contributions of the paper. The authors claim their DNN-based speech synthesis tools are highly effective at misleading modern speaker recognition systems with 50 to 100% success rate. They claim that the model can mimic 60% of the real-world speaker recognition systems, which includes Microsoft Azure, WeChat, and Amazon Alexa. According to a user survey of 200 participants, humans can distinguish synthetic speech from real speech with 50% accuracy for unfamiliar voices and near 80% accuracy for familiar voices. A detailed evaluation of two cutting-edge defenses reveals that they fall short of their goals of either attempting to prevent or reliably detecting speech synthesis, outlining the need for new defenses. Time print. Authenticating USB flash drives. The authors of the paper considered three scenarios of USB fingerprinting and device authentication. Scenario 1, attackers who have no knowledge of the USB devices and the random USB device could be connected to the host. Scenario 2, attackers who know the security measures and know the brand name, model of the approved USB devices and use one with the same brand and model. And auditing Scenario 3, auditing user authentication for all the approved devices, different authorization levels might be assigned. The timeprint design. In order to access the timing information of these read operations, timeprint extends the USB driver to produce a number of extra reads on a selection of randomly chosen blocks on USB devices via the SCSI commands. For process makeup, the timeprint processes performing accurate timing measurements, working the USB flash drive to create a timing profile, pre-processing the timing profile, and determining device acceptance or rejection based on the timing profile itself. The authors claim this is the first demonstrable work of a timing channel within USB mass storage devices, which can be utilized for device fingerprinting, and the system is completely software-based without any additional hardware requirement. A thorough evaluation was conducted on 40 USB mass storage devices, which showed the ability with high accuracy rate up to 99%. Fingerprinting is not dependent upon device brand, protocol, or flash controller. And the next paper is Usable User Authentication on a Smartwatch Using Vibrations. The authors claim this is the first instance where vibration analysis is used for authentication where the default sensors were used without any external hardware support, and this method works independently without pairing with a smartphone. The authors present their user authentication model, which operates independently using static biometric information. User's vibration type is measured by the built-in gyroscope and accelerometer sensors and is calibrated. They describe the method in three steps: vibration generation and measurement, feature extraction, and user verification. Evaluation and results. The authors experimented with low-frequency vibrations and tested feasibility of current models of smartwatches. Equal error rate was chosen as a performance metric. Random forest classification was used to make sure if the model can distinguish between multiple vibration types. User authentication was performed with different scenarios like shifting smartwatch locations on the wrist, arbitrary default users, number of default users, and changing dataset size. The authors chose Apple Watch Series 3 for their smartwatch device to perform all the tasks, and their method received a low EER score of 0.0137 for the first measured signals and proven robust against various tested attacks. And my last paper is Your Microphone Array Retain Your Identity, a robust voice liveness detection system for smart speakers. In the paper, Array ID is implemented and tested for thwarting voice spoofing attacks which uses collection data from a smart speaker. Effective feature set is proposed by the authors which enhances effectiveness and broadens the application scenarios of passive liveness detection. They claim Array ID outperforms existing models. They provide a new large-scale dataset containing 14 different spoofing devices collected by the microphones. The authors propose their model array fingerprint and elaborates three critical questions: how to model the sound propagation in smart speaker scenarios and why existing features cannot be effective, how to extract useful robust features from multi-channel voice samples, and what are the benefits of the array fingerprint. The proposed model is the Array ID, a robust liveness detection system which is built on array fingerprint with other auxiliary features. It consists of modules, data collection, pre-processing, feature extraction, and attack detection. The author used two-fold cross-validation and achieved accuracy of 99.84% and EER of 0.17. The authors discuss impact of various factors on Array ID, impact of changing distance, direction, user movement, changing environment, microphone numbers in speakers, and impact of spoofing devices. Array ID successfully distinguished between different users with 99.88% accuracy. Limitations. The authors highlight user burden on enrollment. They suspect it be affected by poisoning attacks. They also describe impact of noise and other speakers, which affects the temporal stability of array fingerprint. Conclusion. I tried to present all the essential information from all 6 papers I selected. I intentionally picked papers that address similar research areas during the selection process. In the summary section, I emphasized the contributions of the papers and also included a discussion about their methodologies and performance in the survey. And it is apparent from all the previous discussions that machine learning is one of the most powerful tools to work with in the present days, and it is totally up to the user how they want to use it for security or exploitations. Thank you.